Um, all right, so this assignment you're gonna have to create your. It's gonna be probably one of the most like the first like very interesting assignment in the sense that you're gonna get closer to what you see in 3D applications. Of course, still it's a simple 3D world, but now you're gonna have a camera and you're gonna move this camera around in this world, as we can see here in this animation, right? So here you have an actual voxel-based world, and voxels are this kind of 3D pixels, or you can see them as cubes, right, in the world, and they have a fixed size. And these cubes are walls. We have a ground that is green here, and they have a sky box that is also a blue box. So the whole world is made out of boxes and one plane. The plane is this huge green square at the bottom, and then you have a cube as a sky and many cubes as walls. Okay, and you're gonna have to place these cubes in the world and be able to you'll be able to place this camera and move this camera around. Also note that cubes are textured. So this is another part of this assignment. So as usual, we have same structure. Here are the features you're going to need to implement. Here are the instructions to get that done. In this assignment, we are still kind of cleaning things up a little bit. So if you open the description today, maybe you're going to see some like kind of messy descriptions down here. But I'm putting everything like in this the regular bullet points type of style. So we get things to be the same. Okay, there's three main ideas to talk about today, and they are this idea of camera, right? How to get a camera in the world. This has a lot of things to talk about, itself. But I'm going to try to be brief and give you the main ideas to get this assignment done. The other idea is textures, right? How to put textures on objects. And the third idea is how to build a world out of these cubes, right? It's kind of like putting everything together. So I'm going to actually start talking about textures, then talk about cameras, and then maybe if you have time, talk about how to build a world, which I think is perhaps the easiest part. Any questions before we get started? Okay, so let me open our previous project. This was lab 3, and let me open this guy. Lab 2. Oh, it's still like assignment 2, right? This is not. What? Ah, here. Sorry. Yeah. So we had this cube here from the previous lab section, right? Again, this code is uploaded to Canvas. This is a spinning cube, and it has different colors in different faces. This was still part of assignment 2. We're going to reuse some of these ideas for this assignment. Okay, so first thing I want to do is make a copy of this guy. Call it, let me erase this. Call it assignment 3. Libraries are the same. This is the same. Let me open this close this project here. How to remove this? Where is it? Remove project folder. Get lab 4. And okay, let's see. All right. And first thing is to rename these files. Here in the HTML, we get the assignment 3 here. And I think that's it. Right, and then here we're gonna load assignment 3. Oh, it's tab 4. Okay, everything's fine. I'm gonna now let's start talking about how to put textures in this cube. Okay. But first, let me actually get a texture here. I'm gonna actually see if I find the same texture from the video, from the animation. I have it probably here. I have it. Yeah, I have it here. So this is a JPEG file that is that block texture, right? That you saw in the animation. I'm gonna put this in a specific images, or maybe text. Those are textures. Maybe let's call them textures. Okay. So we have this file there. The idea is, okay, we want to load this file and then put them or map this texture on the faces of the cube. Okay. Okay, let's start by loading this file. There's a bunch of stuff to do to get this done. First issue is how to actually read this file, right? We're gonna use let me do this in our main function, okay? Or actually in this is our JavaScript file. I'm gonna make a function here. Where? Update, maybe up here. I'm gonna say make a function here. Load texture. Okay. And basically, what this does is I'm gonna just load this from the file system. Okay. So to do this, we're gonna have to create an image. So this is JavaScript. This is a JavaScript built-in class that literally creates an kind of an HTML image for us, but in JavaScript, right? So if I type this in the console, for example, let image equals new image like this, right? And I print this. It's actually it's an HTML image tag. So you created it dynamically using JavaScript. That's what we just did. Create an HTML image dynamically. Okay. Then we need to pass the source of that image. So where is this image stored, right? So where is this image stored in the disk? And it's textures block. We want to pass this path here. Textures / block JPEG. Block.jpg. Okay. And this path is relative to the HTML document, right? Or to the JavaScript and HTML document. So this is right. So this is the path we want. The root here is this main directory. Okay, so if I do this, for example, I could try the same thing here, right? I could say source equals to texture dot block block.jpg. This is nothing really happened, right? Let's see. Let's try to print this again. Oh. Okay. Well, nothing happened on the website on our application, but actually we see that we changed the object to have the source attribute now to be the path of the file. So this is similar to actually adding an image here to the page, but through JavaScript dynamically. Okay. But now I need to tell the JavaScript function, my function, to do something when this image is loaded. So the way to do that is through the onload attribute. So you say image dot onload, and this is a function. This is a function that I have to pass, which is, so this function, or this function is called when the image is loaded and ready to be used. Okay, so remember that in JavaScript there is, it takes some time. It takes some time for the JavaScript to load files, because it's asynchronous. Like the JavaScript loads files in an asynchronous way. Because, for example, this was designed to be a client-server type of architecture, right? The JavaScript runs on the browser, and the image is sitting somewhere in a server. So the server is not located at the same machine, as the client. So it takes time, right? You run a request for that image, and then you wait for the response. And this response might take some seconds, depending on where this image is. It turns out the image is in the same computer for us right now, because we're running this application in our computer, and both the browser and the server, it's actually the same machine, but still takes some seconds. And in source code, this means that the call here, this function is not called immediately. There is some time for this function to be called. So these lines are going to be executed. This line is executed, but what is inside the function takes some time to get executed. So here inside, we're gonna print. Actually, let me print here image. Okay, I'm gonna print image again. So let's see what happens. Let me call this here now at the bottom. Okay, I'm gonna here at the very end load texture. I'm saying load block JPEG texture. Okay. Let's see what happens. It print the thing, but didn't wait, but didn't print anything here, right? So yeah, actually printed. So it printed this thing here, image. Yeah, okay. So it printed that. It worked. You'll see. Okay, this seems to be working. The next step is to create a Webgl texture. Okay. So we're gonna kind of use this word texture in many ways here. But we, as usual, we create something on the CPU and send to the GPU, right? We did this for the attributes, we did this for the uniforms. We're gonna do that for the texture as well. Which means that we're gonna have a texture on the CPU side, or in other words, in the JavaScript code, and also another texture in the shader, which is our GPU side. So I want to make a texture here on our CPU side. So this is our HTML image. We're also gonna need what? We're also gonna need create a Webgl texture. Those are different objects that, so essentially what you're going to do is you're going to load the image using this image object, set this texture to be this image, and then send it to the GPU, okay? So here we can do lat, for example, texture equals to gl dot create texture, okay? So this is now creating a texture in Webgl, right? And that's it for now, of course. And we have to do something inside here now. So here, what you have to do is we have to kind of map the HTML image to the Webgl texture, okay? And this has a lot of, so we can do a lot of stuff here. There's a lot of attributes that are, sorry, a lot of different stuff to set up. So we're gonna go kind of slowly here because there's a lot of options that you can change when you're uploading textures, and the textbook covers them in a very detailed way. But for now, I'm gonna do like just the straightforward setup, and then we can see how to change the setup if you want. There's a lot of, like, it's very flexible. There's a lot of options here. So one, I'm gonna set up this with the kind of default setup, the default options. So this is, we're gonna start by activating the texture. So let me type this in. So this is a function called active texture. So we need, let me put this here, and I'm gonna say here the steps that we are doing. I'm gonna type in the steps that we are doing. So first, we are enable, or yeah, kind of like, how do I say this? This is gonna be kind of activate texture unit. Webgl, or the GPU has more than one texture unit. This means you can load more than one texture into the GPU. Usually, GPUs have at least 8 texture units. You're gonna use one of them for now. So essentially, I have kind of like up to, let's say, 8 or more texture units, which are kind of memory locations where I can load textures into. So I can have, for example, 8 of these textures at the same time on the GPU, and I can switch between them. And I'm gonna say active texture is the texture 0. Okay, so this is a flag saying that I'm gonna use the unit 0. After that, we have to bind texture to this unit. And there is a type of texture that we need to set, which is the first argument. It's texture 2D. The first argument is the type of texture. It turns out there's different types of textures. The most common one is that the ones we are used to. They are 2D textures where you have a grid of pixels, and you normally use these pixels as colors on geometries, right? For example, like we are doing right now. But there's also another type, for example, of texture in Webgl, which it's kind of a 3D texture that you use. For example, imagine if you want to texture a whole cube, or have kind of a 6-sided texture that kind of wraps around the cube nicely, right? So this is another type of texture that Webgl has. it's kind of a cube texture that you can use to kind of wrap perfectly cubes. And you use that for skyboxes, for instance. And there's other ones as well. So here, you're only going to be concerned about this type for now. And the second argument is the address of the texture. So this is the variable you created. Like this is this texture here. And I'm going to map this to be var because I want to make sure this texture can be written here. Okay. So here I'm just binding the texture we just created to the texture unit, texture 0 unit. Okay. So now I'm going to start setting some parameters, some arguments of this texture. The first one, so let me see here, I'm going to set some texture parameters. Okay. And the first one is kind of the minification filter. Minification filter. I hope you saw in class. I'm not sure if Professor James already talked about textures in class. Maybe it's going to be on Thursday. But this is essentially like how to reduce the resolution of an image, or in other words, the algorithm. Which algorithm to use if, let's say, if the scale of the texture doesn't match the scale of the geometry. So for example, if the texture is 64 by 64 and the side of the cube turns out to be, like, say, 16 by 16, how do you downsample this image, or how do you decrease the resolution of this texture to map onto the cube? So I'm setting that. There's many ways of doing that, and I'm gonna set this parameter to be 1. So this is, we can do this through the function text parameter I. This is texture parameter I. Okay. And the first argument is the type of texture, is a texture 2D. Texture 2D. And this is the argument I want to take. This is the argument, the parameter I want to change. Sorry. And this is .gl.texture mean filter. Right. So this is a flag that maps to the minification filter. Okay. And all the parameters can be changed with the same function. You give the type of the texture and the type of the parameter you want to change, and then the value. And we're going to use the linear algorithm. Okay, don't worry too much about the details. If you haven't seen this in class, Professor James is going to talk about these different algorithms that we can use. Other things could work here as well. It's just like this is one of the kind of most default setups. Okay. So now I'm gonna do this part now, actually. I'm going to do this part. I'm going to map the HTML image to the Webgl texture. Okay. And this is GL text image 2D. Okay. Again, we have the first argument is the type of texture, texture 2D. Second is the unit, I think. Let me just make sure. Let me just make sure, just a second. No, this is, so this is actually an attribute related to level of detail. We're gonna set it to 0 for now, don't worry about it. But yeah, it's just level of detail of this image. We're not going to deal with this right now. And there is, here we have the color model, which is RGB. We're going to have to type this again. So the first one is, where is it? Yeah, so these are the color like components. It has RGB in it, right? And this is from the first one is the source image. The second one is the orange, no, the origin. Yeah, and then the goal. So this is the HTML image, and this is the texture, the WebGL texture. So we are mapping this one to this one. We're just telling that both of them are RGB color models. Okay, and then we have the next argument is how to read these values, which is we're gonna say here unsigned byte. And then at the very end, we have the image here. And this is the image here is the HTML image, okay? So this is the final, this is the HTML image, and this is the WebGL texture. And this is how you map this to this, right? Remember, because we bind it here, then now when you call this function, we know this is already binded, so we can map this to this, okay? And actually that's it. We have to, so we use these 4 functions here to map this image to the WebGL texture. We now have to actually send this to the shader. But before we do that, is this clear? Does it make sense? Okay. So yeah, so loading texture is a bit technical. Is like there's some like theory to learn and stuff specifically about like minification and magnification. For example, if you want to enlarge the image, you also can set. I think there's a max GL max filter here. Wait, hold on. It's texture. It's not showing, but I think there's a max filter here as well. Yeah, not all the things are showing here. This texture mean filter. Okay, so this is it for now. There's other stuff you could do, and the book talks about it, what you could do to like kind of load this texture in different ways, and other parameters you could set, okay? But let's keep it simple. Let's just do this for now. Okay, let's run this, see if we didn't get anything wrong. Yeah, what is the problem? WebGL, no. Choose string. This is Simon 367 here. Let me see if I made a mistake. Parameter gl.texture2d. Invalid texture target. But there is a problem, cannot read properly to string of undefined. Active texture, bind texture. Let me see something here. Let me see what happens if I comment this out. Okay. Now, okay, the problem is in this line. GL texture mean filter. It's correct spelled. Oh, this is texture 2D like this. Okay. Yeah, there you go. So here, and this is the error I was expecting, honestly. So if you look at the assignment description, the very first item says start a local web server. And I mentioned the idea of web server before, right? Actually, in the very first lab section, we did an example of how to start a local web server. And I talked about how that would be important for the future. And this is the first assignment where this becomes really important. And again, this has to do with the fact that the browsers, they are not allowed to load files directly from the browser, from the file system, right? And this is security definition because, well, it would be really weird if browsers could access your files, right? Imagine if Google could write, or any other website could write a JavaScript file that reads anything in your file system, right? Anyone could read your stuff. So this is by default not allowed. What you can do though is you can request a file to a server, and that's what normally is done. In here, we are kind of doing a little hack that is by like kind of doing this approach of loading an image, but this is not normally how you do it. So that's why actually the browser complains. It says, well, I don't like this that you're doing. You can't do that. I'm not going to let you do that. What you can do to solve this problem is open a web server. So let me show you quickly how we can do that. Right? Well, there's different ways of doing that, different frameworks for doing that, and different interfaces. What I'm going to use is I'm going to use a terminal here, and I'm going to go. If you're on Mac, this is a terminal application. If you are on Linux as well, you can open a terminal. If you're on Windows, now I know it's possible to do open terminals that are kind of Linux-based or shells, like bash shells on Windows nowadays. So you can also do that. Or you can also look it up how to open a simple server in Windows using, for example, I'm going to use Python here. And this, I think, is the easiest way. So I'm going to navigate to this project here, to this folder. I think if I just, on Mac, if I just drag and drop, yeah, I get that directory. So I'm going to just navigate to this directory here. I see all the files in there, right? And I'm going to type Python 3 -m http.server. So what this does is it opens a server on the port 8000. Okay, so now if I do this, localhost 8000, I see now my files. Right, this is my HTML, this is my JavaScript. I see the same files here, and these are the same files. And now I'm going to open the HTML through the server, and here you can see in the terminal that the server got the request and sent the page back with all the files in it, right? So see, like it sent all the files to my browser. So same server is running the local computer, but now we have the kind of real world going on here. And as you see, the browser doesn't complain anymore. Okay, so because now we are using the real structure, kind of the expected way of loading files. And note here that the last file that got loaded was the block JPEG file, right? Because this happens after I load the page. It takes some time for the browser to load that file because I'm requesting it here. Okay, so this is it about servers. That's the only thing we need to do. When you run this on your public web page, when you upload this to your public web page, you already have the campus server for you, so you don't have to do anything extra. You just upload your files the same way, and this is going to run on the campus server. So you don't need to do anything extra. It's only when you're developing the page that you're going to have to do that. Okay. Is it clear? Do you have any questions? Okay, I'm gonna move forward then. So we still don't see the texture here, right? Because now we still need to send the texture to the shader. Okay, we haven't done that. And to send the texture to the shader, we're gonna have to create a variable in the shader to receive that that texture, right? So let's go to our shader. And here I'm gonna only load this in the fragment shader because I wanna use the texture to set the colors of the fragments. So here, what I'm gonna do is I'm gonna create a uniform variable. Again, this is the same, the texture is gonna be the same for all the vertices, right? What's gonna be different for all the vertices is gonna be the UV coordinates, but the texture itself is the same. So we're gonna make here the type that we use for textures is called sampler 2D. Okay, this is a 2D texture. I'm gonna call this U sampler. And again, this is in uniform. We know how to set uniforms, right? We know there is some sort of gl.uniform function. Let's go. Where is it? We know there is something like this. Where is it? That we use for, we use in the matrix. We use, no, not here. Where? Here. We know there's some sort of function like this, gl.uniform. This is for matrices. There is also one for textures. So let's use that. Let's go up to the, here we need something like gl.uniform, and we need something like texture, right? But the one that the actual function is uniform 1i, and this is, we're gonna pass here the U sampler. Which is actually the variable. Before doing that, yeah, the variable that we're gonna have to load from the shader, right? And this is the unit 0. So what this does is actually send the texture to the shader using unit 0, or texture unit 0. But what is uSampler, right? uSampler is, we have to access, remember, is the address of this, the uSampler variable of the texture in the shader. Remember, we always do something like this, right? We always have like lat uSampler. You have to get the address, gl.get uniform location. You always do this, right? gl.program. This is how you set any uniform. And then here you have the name of the variable. It turns out this can be global. I don't need to do this every time. So I can do this here. Let me say like global uniforms. And this becomes this global variable now. I maybe can do this. Let's see, I can do the same approach. Where is it? Where's my model matrix? Oh, here. So let me follow the same approach. I'm gonna copy this and put it there because we already have our model matrix here. I'm gonna have this here, set it to null. And then in my main function, I'm gonna actually load this. Where is it? Where here? I'm gonna say retrieve texture uniform. This is gonna be uSampler. Okay. So now it's kind of consistent with what we did before for the matrix. Remember, this is also an uniform. So same approach. Let's check stuff. Here I update the uniform. With this line, I'm essentially now changing this variable to be the texture. Okay, let's run this, see what happens. But I'm not using it, right? I'm still not using it here. So I'm just declaring it and loading it, but I'm not using the color. So I shouldn't see anything different. Okay, but no errors. That's good. Any questions? Like in how to set the uniform for texture? Cool. All right. So next step is now how to, let's use this texture to change the colors of the image. Because essentially that's what we're doing, right? We're gonna grab the colors or sample. That's why this is called sampler. Because we're gonna sample colors from texture and then set it to be the fragment colors. It's different than giving a solid color like as an uniform. We are sampling from this texture file now. And for doing this, we're gonna need to change our shaders a little bit. First of all, we're gonna have to, let's make a color function here, or texture. Let's make a vector, maybe vector 3, vector 4 actually, sorry, vector 4 texture color. And to sample from this texture, we have to use the function texture 2D. This is a special function in the fragment shader or in the GLSL. Here we give the sampler that we need. And here is the position. It's a position in that image. So let me see if I can open up Sketch here. Let's see if I can show you something. So where's it? Wait. Let me plug my tablet here. See if it works. Okay. So texture is normally represented as this 2D grid. Again, as usual, it's laggy, but hopefully. It's very laggy. Oh my God. Try again one last time. Okay, this is better. We call this coordinate U. Yeah, this is tricky. And this is V. And the texture is here. Right. In this case, is our grid, our block.jpg. And normally the coordinate system of textures is like this, right? You have here we have 1, 0. Here is 1, 1. And here is 0, 1. Okay. So when you are sampling from this image, you want to give a position here. Let's say the middle. That's right. Let's say let's say 0.5, 0.5. And then you grab the color, let's say, of that pixel. You grab that color of that pixel, and then you use that color as your final color of your fragment. And so if this was blue, or maybe this is like a blue. Let's do RGB. Let's do RGB. Maybe this was 0, 0, 1. Okay, so this is blue. So if that pixel is blue, then our fragment is going to be blue. If in our case we have kind of a brownish type of texture, which is block, so most of the pixels are going to be brown or black, right? So I hope this makes sense. But we have to give a position here to sample from that image, and that position should go here. I'm going to call this is a vector 2. We're going to call this UV. I'm going to call this UV coord, something like that. And I'm going to, for now, just make it hard-coded, 0.5, 0.5, okay? And give it here. So this is vector 2. So this way, we're going to sample from always the middle of the image. Let's look at our image. So the middle, let's see, middle is going to be this kind of brown, like this pixel here probably. Right. So we should see the whole cube kind of this color. One of these kind of, I think is this one, or like this one, but I think it's like this one. So you should see the whole cube using this color because we are sampling exactly that position of the texture and setting the cube, setting the fragment. Now you're doing that. Now you're, and this is a texture color, so we can just do this because this is vector 4 already, and this expects vector 4. So now I'm just reading the color from the texture and setting it to be the fragment color. Let's see what happens. There you go, right? So now we are reading the texture reading the color from the texture. And we could play with this to get different values. Maybe if I put 0, 0, they're all kind of similar, but 0, 0 is a little bit brighter, I think. Let's just see the change. Yeah, it's a little bit brighter. The trick now is that we need different positions for different vertices to get the whole texture on the face. So we want, for example, the top left here to be, let's see if I can show this together. We want, so if this is, well, let's see if I can draw this. Try to draw this. It's crazy slow. If I can, it's going to be hard to draw a cube here, but let's try. If this is our cube, we want this vertex here to have values 0, 1. We want this vertex here to have values 0, 0. We want this vertex here to be 1, 0, and this vertex here to be 1, 1. But see that this is for this face, right? This is for this face. For the other face, for the top face, we're gonna have to duplicate. Remember that we actually model this cube as a bunch of triangles, and for each face of the cube, we have 2 triangles, right? So essentially, this is actually made of triangles, right? And we duplicate these vertices. For this vertex is duplicated for the front face, for the left face, and for the top face. So for every face, you have a different copy of this vertex. So for the front face, you want this value to be 0, 1. For the top face, you want this value to be 0, 0. Right? Because you want the texture to start here and then go all the way like to the top here. Same is for the top face. This should be 1, 0, right? And so on and so forth. So the same for this vertex, same for this vertex. So for each vertex, for each face, you're gonna have to map these values manually to get the texture right. I hope this makes sense. That's what I'm gonna do right now in the code, okay? I think it's visible to you that we're gonna need an attribute to store the UV coordinates, because every vertex has its own value, right? It's different than a uniform. Every vertex has its own value. So essentially, we're gonna have an attribute variable, which again can only be created in the vertex shader. So we have to use that same approach of an attribute here. Let's call this a text or UV coord, or let's just call it UV. It's simpler. And then you're gonna use, again, a varying here, vector to a UV to send this to the fragment shader. So similar approach here. You have this is UV. Okay, let's make this capital so we actually keep consistent name. UV. Here you have VUV equals to AUV, and this varying goes to the fragment shader as well. Put it on top. And now we can give this guy here. This is where I was previously using this placeholder variable UV coordinate that I was setting by hand, like in a hard-coded way, but I want to get rid of this because now my coordinates come from the variable. Okay, does this make sense? I want to go slowly here. Okay, cool. So again, it's a varying, it's an attribute variable. And that means you're gonna have to create a new buffer to set this value. So let's go down there. And remember, here we have a buffer per position. We have a buffer for color. We're gonna make a new buffer. First of all, we're gonna get the UV get attribute location gl.program shader, right? We're gonna retrieve the variable from the shader. We're gonna now set up this buffer or this attribute pointer. Sorry, not gl.vertex attribute. Let me copy from here. Pointer. Sorry. Sorry again. I said something wrong. We are not creating a new buffer, right? I'm just interleaving the data in the same buffer. I think this nomenclature is going to come in the book, and in the book they show different ways. They show that you can always create a buffer for each individual attribute. What I do here is a different approach, which tends to be faster, which is you interleave all the attributes in one buffer. So essentially, we should call this not only a vertex buffer, but maybe a vertex color, now UV buffer, because it has all these three components per vertex. If you want to be consistent, I think we can. Yeah, let's do this. Let's rename this just to be consistent with the data that we are passing through this buffer. Okay, so you have this UV data now. And if you don't know more about the other format, is essentially you have 3 of these guys, each one for each attribute. And then you have to make sure to enable all of these attributes, all these buffers correctly. It's another approach. I think the book talks about it. So this isn't following here. We are having the same idea here, using the same idea from here. Right? First argument is the attribute. Second argument is the dimension of this data is only 2, because this is UV. Also float type. We don't want to, this is not normalization. This is, I forgot now what this is. But I don't think we need, I don't think we need to do this. Vertex. Yeah, normalize. Yeah, we don't want to normalize. Sorry, I forgot. Size has changed. Now the whole size of a vertex is going to be 8. Why 8? Because we are adding to 6 2 other points. We are adding U and V. So the whole size now is 8. And we're going to start reading the UV from the 6th position. Why 6th? Because this guy starts at 3 and has size 3. So then we start from 6 and then we read 6 and 7. Okay? We read 6 and 7, which is our UV. Later, then we now enable vertex attribute array. UV. Okay, this is it. Right now we set up our attribute to read from a buffer. We just need to specify the data in the cube now. Okay, is this clear? Cool. Okay, so to make things faster, I'm gonna actually change the cube to be a triangle. Sorry, because it's easier. I'm gonna let as an exercise for you. I'm gonna to actually do the mapping for the cube. Triangle is a new triangle. And this is it. And here we can draw a triangle. Let's see. Oh yeah, this has to go away. So we got these errors because, yeah, I expected that, because our vertices don't have the UV positions, the UV values, right? Here we didn't add the UV information. So the WebGL is complaining because I think the dimensions are not matching. Also, here we have to divide. Remember when you're drawing the arrays, we are drawing triangles, and we were dividing the length of the vertices of the geometry by 6 because we had 6 data points per vertex. Now we have 8. So this is something that we have to change as well. But also here we need to pass, remember, this is X, Y, Z. This is RGB. Now I want a texture UV coordinate here. And I'm gonna say this is 0, 0. Right, let me draw this. What I'm doing here is for the triangle. It's essentially, oh wow. No, yeah, this is not gonna work. It's not gonna work. Try again. It's too slow now. No, forget about it. What I'm gonna do is, let's see if I can do this. Yeah, no, I don't know what's going on. Yeah, it's very buggy. Yeah, it's. I think my tablet's complaining. Let me try to. Okay, one last time. Triangle. I wanna put here 0, 0. Yeah. I want a 0, 0 here. Okay, I want a 0, 0 here. I want 1, 0 here, and maybe 0.51 here. Okay. Sorry about this delay, but yeah. So 0, 0, 1, 0, 0.51. 0, 0, 1, 0, and 0.51. So these are my UV coordinates for the first or top. So this is a top, no, the bottom left vertex. This is the bottom right, and this is the top vertex. Okay. Now let's see what happens. There you go. You got a texture mapped to the triangle. Right? And see how cool it is. It's actually, like, this is a square texture, but it correctly samples the texture. And we see this like kind of square here being like cut. And that's it. For the cube, you would have to do this for each vertex here, right? But turns out like it's not that hard, because I mean it's very easy. It's all zeros and ones, right? For a cube, so it doesn't take too long to actually do this. But I recommend you kind of drawing on paper first, this idea, and then you just go and copy the values to every face here, and that's it. Okay. For the square, we can do it. It's not that hard. I think for the square is like, again, this is top left corner. So you want this to be, this is 0, 0, 1, top left. Bottom left is 0, 0, 0, 0. Bottom right is 1, 0, 0, 0. Top left, 0, 0, 1, 0, same as before. Top right corner, this is now 1, 1. Bottom right is 1, 0. Okay. So now from the cube, let's check now the cube. I'm not going to do it because it's going to take too much time. And we still have to talk about camera. But you can try this. Let's try the square. Let's have this square. Let's get rid of this guys. Let's have a square now. Square. Use square. Oh, square. Comment this out. Square. Boom. Okay. Hopefully. There you go. Right. We got the right mapping on the square as well. And for the cube, you just now extend the same idea in 3D. That's it for textures. Any questions? Cool. Let's switch gears now and talk about cameras.